All right, particle motion. This is real similar to what we did in the last unit where we have function, first derivative, second derivative. We're just going to call it position, velocity, and acceleration now. So position is like my original function. Most of the time it's called s of t or x of t. I'm going to write over here. That's kind of like our f of x. Velocity, most of the time we're going to call it v of t. That is my f prime of x. And acceleration is a of t. That is my second derivative. So we're going to be doing pretty much all the same things we did from the last unit. You just have to there may be different words in the problem that's going to tell you what you have to do. Good news for you guys is that you are going to get to use a calculator on this quiz that is Friday. So you don't have to worry about doing any calculating. All right, so here's a little bit more about the first two. Position, s of t or x of t, is the distance from the origin at time t. So what do you think some units might be that we would give for distance? Meters, centimeters, yep, all the meters, feet, miles, yes, we could go on and on. Plenty of options, but if it says one of those, we're talking about position, distance from the origin.
Memorize like conversions between like.
No. No, a lot of times on the AP exam, they're going to give you points for having the correct units. So they'll tell you what some of the units are in the problem, and then if it's helpful for you to realize position is always just a distance unit, then you know what your answer should be in. For velocity, that's the instantaneous rate of change of position with respect to time. So that would be v of t or ds dt s prime of t. Some units we might have for this would be like meters per second, miles per hour, feet per second. So we have a distance over a time. Those are going to be our units, distance over time. The sign of v of t indicates the direction of motion. So it'll say in the problem, like, you know, a particle's moving left or right. And so negative would represent left, positive would represent right. Or it might be something that's going up or down.
So just the derivative of position?
Yep, correct. A lot of our justifications for this unit are going to be pretty much the same justifications we used for the last unit. All right. All right, for velocity, when v is greater than 0, the particle is moving to the right or up. Again, it'll say in the problem what your options are. If v is less than 0, the particle is moving left or down. What do you think it means if v is equal to 0?
It's not moving?
Yeah, it's at rest. A lot of times you'll see this when it's changing directions too. For a particle to change directions, v of t changes signs. That's kind of like our functions. If we went from increasing to decreasing at that relative max, the velocity is 0, the slope is 0. Speed is velocity without direction. So if I don't want the sign, if I don't care about the sign, I could just take the absolute value of it. So absolute value of velocity tells me the speed. In the problem, it's going to say how fast So if you see the words how fast, your answer needs to be positive. Acceleration. A of t is the instantaneous rate of change of velocity with respect to time. So we're taking the derivative of velocity, another dividing by units of time. So our units, anyone know what some units of acceleration might be?
Meters per second per second.
Yes, meters per second, or meters per second squared.
And then basically you can change that to hours.
Yeah.
and-
Exactly. Any distance over a time squared. So A of t is the derivative of velocity, which is v prime of t. It's the second derivative of position. I know. It's like the Mondayest Monday today, with it being rainy and everything outside too.
Oh my God, they decided not to get an umbrella.
Nice.
He has great ideas.
Yeah. All right, speeding up and slowing down. Speeding up is when velocity and acceleration have the same sign. So what you're gonna do is make a sign line. Remember we did this when we were trying to say, where is the function both decreasing and concave down? And we were trying to see where they overlap. That's kind of the same process here. Is you're gonna find where velocity and acceleration have the same sign is speeding up, opposite signs is slowing down. Yeah, I'm kind of ready for that time change because it's like way too dark
When is it?
this weekend. It's fall back this weekend. Yep, you get an extra hour of weekend. Babies and animals are the only ones who don't understand the time change. So I will be up at probably, it'll look like 6 a.m. I mean, it'll be the same time, but I can usually get them to sleep till 7 or 7:30 on the weekends. It's gonna look like 6. All right, I think I got one more thing. Displacement. Do we know what displacement is? Change in position, yeah. So like if I start right here and I walk all around the room, whatever, if I want to know the distance I traveled, I have to add up everywhere I walked. If I want to know my displacement, I take where I started minus where I ended, or sorry, where I ended minus where I started, and that is your displacement. So I might write this as S of B minus S of A, because I'm using the position as S of T or X of T. Final position minus initial position. All right, and I think my example problem is actually the first example in your packet. Oh wait, sorry, I forgot. I have one more thing to tell you. And then we'll do the problem. Okay, average velocity. All right, average velocity, this is the one people mess up because you see the word velocity in there and you're like, we need to use the velocity equation to calculate this. You actually don't. Average velocity is just like the average rate of change of the position function. So you're gonna do S of B minus S of A over B minus A. Remember that? That's just the slope formula, but you have to use the position function. Because even though you're doing a change in distance over change in time, we're getting a slope, so that's how it's related to velocity. Average velocity is the slope formula. Instantaneous velocity, that's where you just plug in whatever value into your velocity formula. So if it said, what is the instantaneous velocity at t equals 3, you just plug in 3 into the velocity equation. If it says, what's the average velocity over the time interval 0 to 5, you use the position function and calculate the slope. And time cannot be negative. Okay, that's the last thing. So now, once you get that written down, open up your packets to worksheet 1. We're gonna do the first example together. Are you gonna get a packet? And I don't know what happened when this went to go print, but like the equations did not print. So I have it right here. This part did not print on your paper. So write down the equation h of t equals negative 5t squared plus 20t. After we do this example, I'll give you all the equations. I don't know how in the world that happened. All right, Bob stands atop a cliff. He throws his math book into the air with an initial upward velocity of 20 meters per second. As a result, its height above where he threw it, h of t meters after t seconds, is this equation, negative 5t squared plus 20t. The upward velocity of the book is the derivative of height with respect to time. Write an equation for the velocity. Okay, how do you think we might write an equation for velocity?
Derivative?
Yeah, just find the derivative of that. What is it?
Negative 10 speed plus 20.
Yep. Okay, what do you think we should call this equation?
V of h prime.
You have options. You can write h prime of t and then move on with your life and be done with it. I like to use v of t. However, if you want to use v of t, you can't just pull that out of thin air. You have to define it. So at the start of all these problems, usually I'll say, okay, if h of t is my function, h prime of t is v of t, and h double prime of t is a of t. I don't know if I'm going to need an acceleration function, but if I do, now I've already got it defined. So you don't have to do this. You can just call it h prime of t. I just like to use v of t and a of t because I'm like, oh, that's velocity, that's acceleration. All right, next. How fast was the book going at time t equals 3? Was it going up or down? What do you think we're going to do for this one? Plug 3 into h prime of t. Okay, so v of 3 equals negative 10 times 3 plus 20, which is what? Negative 10. Okay. Yes, good catch. I was going to highlight this real quick. It says how fast, so what is my answer? 10 what? Meters per second. Yes. So 10 meters per second, that's the answer to how fast, and it is going down. And we know that because v of 3 is less than 0. So just like our same justification for decreasing, it's pretty much the same thing. Okay? V of 3 is less than 0. That's how we know it's going down. At time t equals 3, was the book above or below where Bob threw it? If we're asking like where it physically is, that's the position function. And really, I'm kind of wondering what the displacement is here. It's saying like from the beginning to time t equals 3, where are we? So let's find h of 0 and h of 3. What is h of 0? 0, okay. H of 3. compare these two, if I were to subtract, was it above or below where he threw it and how far?
Above.
Yeah, above by how much?
15 meters.
15 meters above. So displacement, you just subtract those two. At, yeah. At what time is the book at its highest point? How do you know? Okay, so let's think about this. Highest point, what word is coming to mind? Maximum. What?
Would it not?
Is
Is the negative at the top?
where?
Isn't it like
H
H of T?
of 3. So if I plug in 3 here, that'd be 9 times 5 is negative 45 plus
Oh, it's
60.
20.
Yeah. Okay, so highest point, I'm thinking maximum. So then we got to go back to last unit. Are we talking absolute or relative?
Absolutely.
It is absolute, but we don't have an interval. So it's probably the same thing. And let's think about it. What is this function? Negative 5t squared? Upside down parabola. Isn't the relative maximum the same as the absolute? So our process for this is going to be to take the derivative, set it equal to 0, and make a sine line. We already have the derivative, right? Velocity. So negative 10t plus 20 equals 0. So t equals what? 2. Okay, I'm going to make a sine line just to verify this. I'm going to make it start at 0. I don't want to go to negative infinity on these problems. Put 2 on here. Let's see, between 0 and 2, are we positive or negative? Positive. And then after 2? Negative. Okay, so goes up and then down. So yep, that is a maximum right there. So at what time is the book at its highest point? T equals 2. How do you know? What do you think our justification is?
Because it changes from positive to negative.
V of t changes
Changes that.
from positive to negative. Real quick, you guys said this was a parabola, an upside down parabola. Do you remember from Algebra 2 how you might find where that maximum occurs? Yeah, x equals negative b over 2a. By the way, anything you know from a previous math class, you can use that to answer the question too. You don't have to use calculus. I want to show you something real quick. Ax squared plus bx plus c equals 0. Okay, if I wanted to find the critical value of this, don't we take the derivative and set it equal to 0? What's the derivative of this?
2ax
Plus b.
plus b.
What do you get when you solve that for x?
Negative b over 2a.
Negative b over 2a. That's where that came from. Isn't that cool? That's the only critical point on a parabola. So it has to be the max or min. Okay? All right, let me show you guys the rest of this worksheet because the equations did not get printed. So we already did number 1. Let's scroll down to number 2. There's the equation for number 2. I'll give you a second. Jot that down. 18t minus 4.9t squared. Okay, and then part C also did not print. It should say find d prime of 1 and d prime of 3. And then flip to the back. All right, number 3. Okay, there we go. There's the equation. S of t equals t squared minus 3t plus 2. Looks like I think you got all of the questions on there. Then let's go to number 4. Okay, here's number 4. There's the equation for that one.
I said print everything but the equations.
What? Number 4?
Yeah. So that's number 4.
Yeah.
Huh.
have no idea why it did this, because clearly they're in the document. I don't know. It's never happened. And I looked at it through the rest of the packet. They didn't do it on any other worksheets. I don't think.
Why is it y is equal to 2, but it's x and t on 4?
They're just saying a particle is moving along the line y equals 2. That means you know it's moving left and right. And this is the function that gives its path. Okay, part A, that's t is greater than or equal to 0. And then number 5. There you go. And they love this notation on the AP exam. We've got 2 different particles. I think we're talking about 2 cars. So they have S sub A and S sub B for car A and car B. Actually, last year's FRQ, they gave 2 different particles, and it was like V sub H, or X sub H and X sub J. They called particles H and J. I don't like subscripts that much. All right, well, you guys can go ahead and get started. I think you can probably finish this worksheet in class today. The answers are already up here. If you're not going to be here tomorrow, is anyone not going to be here tomorrow? Yeah. Tomorrow, I mean, I'll post a video of it, but it's basically just the same stuff, except I think you have a graph of the derivative and you have to answer questions. Yeah. 2. There.
Can you look at my grade 9, please?
Yes, I will.